Hi, hello friends. Welcome to my YouTube channel. Now in this session we will solve the Telangana State Tsgenco AE 2015 electrical solutions. Now in this session the first question is the severity of line to ground and three-phase faults at the terminals of unloaded synchronous generator is to be same if the terminal voltage is 1.0 per unit and Z1 equal to Z2 equal to J 0.1 per unit and Z0 is J 0.05 per unit for the alternator. Then the required inductive reactance for the neutral grounding is. So here in the given question they are saying that the LG fault and three-phase fault terminals of an unloaded synchronous generator is to be same. That is an LG fault, and here we have three-phase line fault. So one is a asymmetric fault, another one is a symmetric fault. Now here the formula is IF is equal to 3 into ER1 divided by X1 plus X2 plus X equivalent. Here X equivalent is equal to X0 plus 3 Xn here. And in case of three-phase line fault, the fault current is IF is equal to ER1 by X1. Only positive sequence reactance will be present in case of three-phase to line fault. Now, in the given problem so this is a IF and this IF both are equal. That is 3 into ER1 divided by X1 plus X2 plus I will substitute X0 equal here, that is X0 plus 3 Xn, which is equal to ER1 by X1. So from this ER1 gets cancelled and we'll substitute the values of X1, X2 and X0 here. So what is the value of X1? So X1 is equal to X2. So here in the given problem they specified it as impedance, but we will consider it as a reactance only. But because in the given question is inductive reactance they have mentioned, not inductive capacitance or impedance. So X1 is equal to X2 is equal to J 0.1 ohm per unit. Sorry, it is per unit. So it is per unit. Now X0 also given. So X0 is equal to J 0.05 per unit. If we substitute this in this equation, we will get it as, so substituting here, that implies 3 divided by X1 is 0.1. So J 0.1 plus J 0.1 plus X0 is J 0.05 plus 3 Xn is equal to 1 by J 0.1. So if we substitute and solve this answer, you will get Xn as J 0.0166 per unit is the answer here. So in the given options, A is the right answer. The next question here is, buses for the load flow studies are classified as A, the load bus, B, generator bus, 3, slack bus. The correct combination of the pair of quantities specified having their usual meaning for different buses. So generally, the generator bus is specified with its active power. So active power P and it's a voltage profile, and load bus is specified with its active and reactive power. And the third one, slack bus. So slack bus is specified with its voltage profile. Second one is load angle delta here. So the option here is 2. The next question here is, The incremental fuel cost for two generating units given by IC1 is equal to 25 plus 0.2 Pg1, IC2 is equal to 32 plus 0.2 Pg2, where Pg1 and Pg2 are real power generated by the units. The economic allocation for the total load of 250 megawatts, neglecting the transmission losses, is given by. So here, the incremental fuel cost for the two generating stations should be same for economic allocation. Okay, so here they are giving that. So Pg1 plus Pg2 has to supply a load of 25 to 50 megawatts. Sorry, 250 megawatts. Now from this equation, these two are equal. So for economic operation, IC1 should be made equal to IC2. So from this, you can say that 25 plus 0.2 Pg1 is equal to 32 plus 0.2 Pg2. So if we solve this equation, we will get it as, so Pg2 minus Pg1 is equal to 35 is equation number 1. And similarly, so Pg2 plus Pg1 is equal to 250 megawatts. Okay, so from this, if you solve, you will get Pg2 as 107.5 megawatts and Pg1 as 142.5 megawatts. So these two answers are not in the given options. So the answer is not available. The next question here is the most appropriate operating speed in RPM of the generator used in thermal, nuclear and hydro power plants would respectively. So in thermal, comma, nuclear power plants, we will use cylindrical poles or cylindrical rotor, so which will have a less number of poles. So minimum is 2 to 4. So ns is 120 f by p. As the poles are less, they are going to rotate at very high speeds. So 3000 here. And in case of hydro power plant, we are going to use silent pole alternators, so which will have a more number of poles, for example say 120. So as n is proportional to 1 by p, poles are high means speed is less, so that hydroelectric power plants, they are going to run at low speeds, and thermal and nuclear power plant are going to run at very high speeds. So option is 2 is right. The next question here is a large AC generator supplying power to infinite bus has a sudden short circuit occurring at its terminal. Assuming that the prime mover input and the voltage behind the transient reactance to remain constant immediately after the fault, acceleration of the generator rotor is. So here normally the accelerating power Pa is equal to m into d square delta by dt square, which is nothing but moment of inertia into acceleration here. So acceleration alpha is equal to accelerating power Pa divided by m here. So the acceleration of the generator is inversely proportional to the inertia of the machine here. So the answer is 1. Thank you friends. Thanks for watching my video. Have a nice day.